Okay, second video. So, students are conducting an investigation on a convex lens with a focal length of 1 meter. They place an object at 1.5 meters, which correctly describes what they will set up. So, let's look at these. Some of these are kind of crazy looking, all right, but remember, you're looking for these 3 rays, okay, that are going to go, one's going to go from the top of the object to the center of the lens, and then it's going to refract through this focal point, this special point on the other side of the lens. You're going to have a second ray that goes through the center of the lens, and then a third ray that goes through this special point down, and then it's going to bend and go this way. So here I see that all of my rays are like bouncing back. Nothing's going through the lens. Okay, so that's not going to happen with a convex lens. So not that one. Let's see, then this one, the first ray looks good, but then the second one looks, there's no second one, okay, going through the center of the lens, and then the third one is bouncing like upwards, which would not happen, so not good. Let's go down to this bottom one. This one, we've got a good first ray, we've got a good second ray, but then this one bounces off this way. Again, not going to happen. My third diagram here looks like the correct one because I've got my first ray, I've got my second ray, and I've got my third ray. Okay, so all 3 rays are correct for this one. Okay, so this is going to be our correct setup. So you want to look for these, for a convex, you're looking for these rays that are going through the lens at different points, and then they're going through the focal point on one side or another, and eventually they're forming an image over here. Okay. Okay. Let's see. So fill in the table. We did this table in class. Okay, so this tells us like for different cases, okay, different types of lenses and object locations, what we're going to get. So I'm actually going to fill in concave first because it's always the same. We always get a virtual image. It's always upright and it's always smaller. And we drew this one in the last video. Okay, this was the concave lens. You see my virtual upright and smaller image right here. So with convex, if my object is out far away from my lens or farther away beyond 2 times that focal point, I'm going to get a real image. Real is always inverted. So virtual is always upright and real is always inverted. And when I'm out farther away like that, okay, I'm going to get a smaller image. One second. Yeah. Okay. Then as I come in closer to my lens, I've still got a real image. It's still inverted. I'm going to get to a point where it'll be the same size as my object. And then closer still, real, inverted, and larger. Okay, so that's, I think that's what we had on the very first page in the last video. Okay, so here my object's getting closer. Okay, it's in between like 2 times F, and so I end up with this larger image here. Okay, so my image size is getting progressively larger. When I'm at F, remember, this is the point where I have no image because I'm on the focal point, so I can't refract through the focal point if I'm on the focal point. And then with convex lenses, when you get really close to the lens, like you're in between that special focal point and the lens, you end up with a virtual image. And it's upright because those are always upright. And in this case, it's actually larger. It's like this big, huge image kind of almost behind the object, but it's on the same side of the lens as the object. So, okay. So now we get into some of the calculations. I'm going to write the equations here just so we can use those for reference. So this is my focal length. 1 over my focal length equals 1 over my distance to my object plus 1 over my distance to my image. And then we also have equations for magnification. That's how much my image and my object size compare to each other. And we can calculate that either by using heights or by using distances. Okay. So we've got a 2 centimeter high object. It's 54 centimeters from the lens, and it's forming an image. So what's the focal length? So let's write some of our, we don't know F, that's what we're solving for. DO, my distance to my object, is 54 centimeters. Okay. And then DI, my image distance, is 43 centimeters. Okay. So I'm going to use 1 over F equals 1 over 54 plus 1 over 43. Okay. And this is a great example where I would have the hardest time getting a common denominator. I have no idea what that would be for 54 and 43. Nor do I want to think about that. So I'm going to divide 1 by 54. I'm going to get 0.01852. I'm just going to put a few decimal places there. And then 1 divided by 43 gives me 0.02326. Okay, so I just converted both of these to a decimal. I'm going to add them up. So I get 0.04178. And with these, just be careful with your decimals and your numbers. Like, don't mix up your decimal place. That's maybe one of the biggest things you could do. Now, this is not my answer. This is equal to 1 over F. So now I've got to do a crisscross or flipping these two, swapping these two with each other. What I end up with is that F equals 1 over 0.04178. And so then if I plug that into my calculator, I get 24, roughly 24 centimeters. So that's the focal length of my lens. That's that distance between my lens and my special point where my light rays bend or refract through. Okay. Then what's the magnification? So they actually give us heights as well as distances here. So we can do either one here. Okay, so maybe we'll try both. Image height is 1.5. Object height is 2. So that's image height and object height. So 1.5 divided by 2 is 0.75. So my image is reduced. My magnification there is less than 1. So image is reduced. Okay. This one, we could use the image distance over the object distance as well. Let's try that. So that's going to be DI is 43 divided by DO is 54. And that gives me pretty close, like 0.7, 0.8. I guess this would round to 0.8. So you can use either one. It just depends on what you're given. Okay, let's see. I think I'm about out of time. I probably have one more video on this final page of the study guide, so that'll be our last one.